Hey, what's up, guys? I'm sure you guys remember this from the simplest way to make a 555 video that I did a couple of weeks ago. So I've gotten some interest in this circuit, and I thought in this video I'd show you how to design your own PCB, get it made, then we'll solder all the parts to the PCB and have this as a permanent circuit. So just in case you're unfamiliar, I'm going to go over this really quick. This is a 555 timer here, and it is in bistable mode, so it's on and off. And that rate is controlled by this capacitor right here. So what we can do is we can change that capacitor for different values, and that will allow us to change the frequency, and the duty cycle there can be controlled from that potentiometer. I'm just looking for another cap here. Here we go. See, in this case, the duty cycle is so fast that it's running faster than the eye can determine. So anyway, you've seen this circuit before. There's no need for us to harp about it here. Let's bebop on over to the computer, and we'll design this in a PCB. Okay, I've got Easy EDA open, which is a web-based PCB design software. And you can use any PCB design software you're familiar with, but if you don't have one, you're just getting started, then you're the guy I'm making this video for. And in that case, just go to easyeda.com. And we're going to start with a new schematic. Okay, so here we are with a nice blank page. We're going to come over here to our parts. I'm sorry, our library. And from the library, whoops, let me close that window. We're going to start out with the 555 timer. So just type in any 555. And we're going to get our 555 timer. So you click on it, and then you drop it on the screen. Then right click. So here it is. Here's our timer. And you can see it has all of our pins. Everything there is good. So the next thing we need is our timing capacitor. So I'm going to click there, and I'm going to bring a timing, or just a capacitor out here. So there's our timing capacitor. And then we're also going to put in an LED. So I'm going to click here, and I'm going to bring out an LED. And then we need to rotate that. So I'm going to click on it, and then come up here and click rotate right, rotate right. So there we have those. And the final thing that we need is a potentiometer, which we're going to bring over here. And where'd she go? Like that. And we're going to rotate it as well. So this time we'll just do a flip horizontal. And then we just need to make sure we're lined up. So there are the basic parts of our circuit. Now we need to start connecting things together. So we come over here to wiring tools, and we're going to get our wiring. And we're going to start here with pin 6. Come up here. Pin 6 connects to 2. Alright. Then we're going to come here from the wiper of our potentiometer, which connects to pin 7. And then pin 6 connects to one end here. The other end of our potentiometer connects to pin 8. just like that. So now we also need to connect pin 2 to our capacitor and pin 3 to our LED. Whoops, I screwed that up. Now, there's no worries. Just click on it, hit delete, and redraw the line. Just like that. What the heck did I do here? Oh. What did I? Okay, that's the one that connects to 2. Oh boy, I screwed this up. Okay, let's click on that there and delete it. Delete it. Try and. All right, let's do this again. And see, that's the beauty of this. You don't really have to worry too much. Because if you make a mistake, you can just come in here and correct it. Boy, and I make plenty of mistakes. Come on. Can I get rid of this now? Ay, caramba. Let's try it again. So 6 connects to 2. And that connects here. All right, there, we got it this time. And then we need to connect 3 to there. Right click twice to get out of it. Okay, so 6 is connected to 2, that's all good. Next we need our VCC, which connects to pin 8. And we'll wire that up just like that. Oh, really? Did I screw it up again? You guys must be laughing your butts off. Okay, and then our reset pin also needs to connect there. Okay, so there is basically our wiring. We need to do one more thing, and that is we need to bring in our ground and wire our LED to the ground and also the capacitor. Okay, so there we have our, oh, nope, guess what, missed one more thing. All right, now we're done. So there's everything wired up for our simple 555 circuit. Now we can come up here, and I just got to remember where it's at. I think it's under miscellaneous. Yes, convert project to PCB. Our new schematic, we'll just call it our super simple 555. Okay, so now it's going to bring up the PCB editor. Okay, so we have our PCB editor open here, and you can see we have our layers, we have some drawing tools, and we have our parts. So the first thing I'm going to do is I'm going to bring our 555 timer here, and then I'm going to rotate it right. Maybe bring it up a little higher, not like that. Then I'm going to come over here and grab our potentiometer, bring it up here like that, and then I'm going to totally miss clicking on the capacitor. Bring up the capacitor here like this. And finally, the LED, I'm going to rotate right. Yes, right. And it goes a little something like that. So now we're laid out. And the next thing we need to do is actually draw our track. So I'm going to zoom in here a bit. And we're going to draw most of these tracks on the bottom layer. So we click on the bottom layer and we get our track tool and we just draw them. Boom. 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 Just like that. Pretty simple. Here. Here. There. And there. All right, guys, we missed a little bit there. The recording stopped and I did not realize it. I apologize. But I'm going to show you what I did. I just added some text so we know the polarity of our input and the polarity of our output, and a board title. And I added some holes, some mounting holes. That's it. Pretty simple stuff right there. So everything is done. And the next thing we need to do is output this as a Gerber file. So we come over here to our main menu. We go to miscellaneous, Gerber output. And again, this is our super simple, oh boy, I type right, 555. We click save. I guess it wants me to do it again. Gerber output. Okay. Then we click OK. And it's going to bring up this next page. And right here, you see where it says download Gerber file. Click that, and you can see right down here, it will download our file. Okay, so that's it for this. The next thing you're going to want to do is upload it to a board producer. So we're going to use JLCPCB. Well, let's go there. Okay, so here we are at the JLCPCB.com page. You're just going to click Add Your Gerber File. Mine's right here. It will upload it. Just takes a few seconds. And there's our board. Very simple. Any changes you want to make here, you have PCB thickness, color, surface finish, copper weight, gold fingers, material details. We're just using the standard FR4. Whether or not you want them to put their little mark on it. And save to cart, pay for it. And that will basically be it. And DHL just left with my boards fresh in from JCLPCB, who in fact are sponsoring this video, so thank you to JCLPCB. Total cost on these, $2 plus shipping, and you get them in a week. So anyway, my super simple 555 timer circuit, you need a potentiometer. The value really doesn't matter. 555 timer, a capacitor, and an LED. In fact, you really don't even need the LED for this. It's basically just an on indicator. So with the value that we have going on here, this is a 20K potentiometer, and this is a 104 cap. We're going to get a frequency of about 700 hertz or so. So I'm going to power up the power supply, and you can see that there. Now, pardon me while I bike things a bit bumpy and try and show you the newly installed frequency counter here. Can I do it? Can I do it? Yes, I can. Barely. But there you see it. I can't really get you guys a good picture. I'm going to have to move my swing arm. 704. There we have it. So that's our frequency with this particular setup. You can easily massage those values for your own setup. So what's next? Next, we open the bag. Pardon me, I still have sniffles. And if you wonder why it's Monday morning at 11 a.m. and I'm not at work, well, here in the U.S., this is a holiday, Martin Luther King Day. Martin Luther King was, if you're not from the U.S., was an African-American civil rights leader who was assassinated in the 1960s. So anyway, there's our PCB Simple 555. You can see most of the tracks on the bottom side. Had to run one on the top side. So now we're going to put it together. You ready? Got your soldering iron warmed up? Let's do it. So where do we start? Well, I generally start with resistors. But since there really aren't any, I guess we'll go with the IC, our 555 timer. All we need to do is line up the notch in the chip. What we got there. And we'll solder it home. Is it going to stay in? Maybe. I hope so. If not, we know what to do. Well, here's a good question. Where exactly did I put my solder? Oh, one moment, please. You know, I'm always preaching the 7 P's, proper previous planning prevents piss poor performance. And obviously, I did not properly previous plan because I forgot where the solder was. But we've got our solder now, so watch this chip fall out as soon as I touch it. Oops. Okay, so now I'm just going to check. Make sure we're sitting nice, and we are. Now, I like to solder chips opposite side to opposite side. It just kind of spreads the heat out a little bit. Of course, one of the key things that you want to do when you're soldering anything with a semiconductor is keep your heat exposure at a minimum. And sometimes that can mean a higher iron temperature that gets you in and out quicker. Okay. All right, not too bad. All right, I guess next we will put in the potentiometer, our pot. A little bit of bendy. Somebody wrote and asked, how do I know which one I was using? I didn't. I just assumed that they would have the most common size. Is it the case? Mostly. Alright, this is going to take a little finesse. I'll be right back. Just so nobody accuses me of cheating, which somebody wrote a week or so ago, and because they couldn't get one of my sketches to work, they said I must be faking it. I'll make sure I solder this here in front of you. I'm just laying it on the table to hold itself in place. Generally, I like to solder while they're in the clamps, but like I said, this didn't want to stay in very well, so it required a little finesse. There we are. Only 2 things left to solder in. Well, boy, I just really can't talk today, can I? Come on, focus. There we go. Not counting our header pins. Next up is a ceramic capacitor. And it doesn't really matter what direction we put it in. Bend those leads out a little bit like such. And we'll solder them in. Lickety split, nothing to it. Get the side cutters. And off they come. Alright, the last component is the LED. Now I'm using a near ultraviolet LED here. And I'm being very naughty by not putting a resistor on it. I didn't design a resistor into this board. I could say I was really smart and I planned on using one on the leg, which you can see if I grab any resistor from my collection, any LED from my LED collection. Yeah, that's something I do. But I tend to use this board driven from a power supply. I'm just going to limit it via the power supply, so it's not going to be an issue. Okay. Now, you could also get away with a yellow LED in here with no resistor. This just doesn't put out much current. Red LED probably pop. Alright, so now we're down to header pins. I just happen to have a selection of them right here. These ones here are our signal drive takeoff. If we're going to use this to drive something else, it's going to come from right here. Now, I know that's not going to stay in when I turn it upside down. So, a little bit of the old duct tape. Engineer's toolkit stuff. Duct tape, WD-40. That's all you need, right? If it moves and it shouldn't, duct tape. If it doesn't move and it should, WD-40. You guys know WD-40 is actually just water displacement, right? It is water displacement formula number 40. And it's mostly kerosene. If you do any machining at all, and I do a little machining on the side, got a little lathe and a little mill, you will know that WD-40 makes an excellent lubricant for aluminum. All right, 2 more pins. These are our power input pins. Going to solder them in. And guess what? I'm not going to show you because you've seen me solder in pins. If you think I'm cheating, then watch another channel. You didn't think I'd do that to you, did you? Of course not. But I am going to swear you to secrecy, showing you the double secret upside down solder. Must never speak of this to people outside of our little fraternity. Kids, do not try this at home. Unless you want to. Well, how do I care? All right. That's it. That's the board. And now, without further ado, and without shutting anything off, God knows I don't want to be accused of cheating, we shall hook up the power. And see what happens. Pardon my phony half German, half French accent. I don't mean to insult anybody. It just kind of gets silly when I'm doing stuff like this. Und now we will witness die Spitten und Sparken. All right, I'm going to turn it on. Cross your fingers. Hey. So far, so good. Now, the question is it really blinking? And you know, there's only one way to find that out. I gotta get these on here. I'm afraid they're gonna short if I put them on like this. Can I hold them? Yeah, okay. Tell you what we'll do. Just to prove that I'm not cheating anybody, the video remains on while I stand up and go to my wire rack. And I am grabbing an oscilloscope lead. So I'm going to plug into the scope here. Firing up the scope. There, you can see the scope coming to life. I will bring this into the picture. And here we go, ground lead first. Yeah, I think I still might end up shorting these. And hit the auto set. That wasn't the auto set. Well, you look at that. Square wave, 841 hertz. So my measurement was a little bit off. But there you go, friends. Everything works. Everything is together. And I've got 9 more of these. And if you're in the U.S., send me your address. I'll send you one for free. If you're outside the U.S. and you want one, if you're willing to PayPal me the shipping, I'll send you one. That's how you design a PCB. That's how you put it together. Big thanks to JLCPCB. Big thanks to all of you guys for watching and believing in me. You mean the world to me. I love this YouTube channel. I love this community. I love you guys. That's it. I'm out. Peace.